Hi guys, this is my 7.3 lab. Um, Starting here in the array producer, uh, we basically create a string array that holds a reference to the test string array. That's the one we're going to get in the constructor. Um, then we have only one method in here, produce. It's basically going to get an index, so the element in the string array that we want to insert at, and then a string that we want to insert into that spot. We're going to use a for loop here and basically work from the end of the array to the index location. So each iteration is basically going to set the current element to be the element to its left. So if we had an array of A, B, and C, and we wanted to insert the D at, let's say, the B location, so the first, so number one, like let's say if index was 1 and we're inserting D for our string, your new array would be A, D, B, because when we move them over, we effectively like replace the very last element in the array to be the second to last element. And then we would end up actually before the final, like that's just through the for loop. So then you'd end up with actually A, B, B, and that's when you set the B that we're trying to replace to be D. So that's this right here. I'm setting the index to be the value. Let's see, if we go to the array consumer class, we'll have a constructor up here doing the same thing as in the array producer. It's going to basically set a string to be the very first value of the array, uses a for loop to shift all the elements in the string over by 1. So it's going to move them the basically the other direction. Instead of moving them to the right, it's moving them to the left. So we're getting like the I sets the current I element to be the element to its right in the array. So if it's A, B, and C, you would instead, through the loop, it would be B, B, C. Actually, no, B, C, null would be the final, because as you move them over, we need to set the last element in the array to be null. Because currently actually it would be BCC, sorry, not BBC. It would be, yeah, BCC, and then we're changing that last C to be null, so there aren't duplicates in the array. And that returns that string that was the very first element. So that's returning it, like we're just holding it, then we're changing the array, and then we're returning that string later, so that the test collections knows what we removed basically. So yeah, so if we go to test array here, we construct like a producer and a consumer here, and then when we call in the produce, the first index is going to be first, and then we actually do it again we kind of like override it. So this is what our array is going to be. It's going to be first and then null, and then because the array is only size 2, so that's the size of the array. So first null, third first, because we're moving it over. The first is getting moved over, and the third is replacing its location. And then we set second to be actually the second element in the array. So you have third and second. So then when we consume the very first, we expect third, which is this guy, and then we're going to end up with second null. Then when we produce into the number 1 index, which is like the second element in the array, we produce fourth. So you have second, fourth, and then when you consume, you expect second, and then that's going to be fourth null. So I can run that and that should work. There we go. That all worked. So then when we move on to our array list, let's start in the producer. Basically creates a array list, same as kind of with the array producer. It's just an array list this time, sets a reference to it. Then we get an index and a string, pretty much identical, but instead of having to use a for loop, we can use just list.add and then use the index and the string that we desire to change. So the nice thing about the array list is that it automatically resizes for us. So that's why we don't really have to use that for loop to shift the elements. We're not limited by the size of the initial array. So as we change it, it's just going to automatically, if the array is out of bounds, it automatically creates a larger array for us and copies over the data. So in the test array, that's why I kind of leave them open here, because I'm trying to like show that like this isn't like a closed array. Like we don't have a set length. Like it can be larger if we need it to be. So, but I guess it would still be just a array size of 1 at first, because the first index is first. Then we're gonna do a second one of third, and then the second index again, but second. So that would move the third over. So it does the same thing by moving it over, but this time instead of the third being basically kicked out of the array and replaced, it just gets moved over and the array changes its size. So then when we consume, we expect first. We add fourth to the second. So now the second is in 0. The third is in 1. So when you add fourth to 1, it kind of splits it and goes in between them, because this guy stays the same. Fourth is now in 1 and third gets moved over. So then when we consume, we expect we expect second, and then the array should be fourth and third. We expect fourth, array should be just third, and then when we consume that last one, the array should be null. So if we run that, there we go, that worked as well. Then down in, let's do the tests, the hash maps. So I'm going to close these out in the meantime. So the hash map sets up a map and references it with the this.map. And then the produce method gets 2 strings. So these maps have a key name string and a value of string as well. So a lot of times you see like string and integer or integer and string, but this time it's just 2 strings. The key name is going to be what we assign each entry in the hash map, and then the value is going to be the actual value of, like in this case it's .java, .cpp, .c. So when we add it to basically when we use the produce method down here, it's going to use map.put to assign or overwrite the key values entered into the map. So I think in the test, we override it once. I think it's the Python one we override. But so we have Python as our key name, and then we set the value to be like PYC. And then we actually overwrite that by calling with the same key name and doing PY. So instead of creating a new, like 2 keys with the Python, it's creating 1. And that's like the hash map is like really useful in that way, because it does not allow duplicates in any way. And then each key maps to 1 value. But yeah, so that's like kind of like the best part about it, is like it's really easy to manage, and it doesn't like allow weird duplication or stuff like that. I ended up using it for my architect assignment as well. So the consume does the same setup, creating a private hash map. The string from the test collections is going to just be the key name that we want. So we use the remove, the map.remove, and that's going to basically just look up that key in the hash map and remove it, as well as returning that key name. So we don't have to create another string and like assign it to be the one we want to remove and then return that string. We can just return this whole thing is all we need, and it will return the key name as well as remove it at the same time. So it kind of works as a dot remove and a dot get. So down here, so the producer is going to add this. So our hash map is going to look something like that. And then we add the C and then the C++. And one thing to note is that the hash maps don't have any order to them normally. So when you add them, it's not guaranteed in any order they're going to end up in. I'm not even sure if this is the exact order they do end up in. I just wrote this down so I can understand it. So then when we consume Java, the hash map will look something like that. Then we add Python, so it will look like that. And then we try it again, but that will just override it. So you end up with just python.equals.py instead of .pyc. And then we consume Python, and it should just look like that in the very end. So I did want to test this, like just to show that it does work. So yeah, so this is exactly what it's going to print out down here in this, in the debugger here. So last one is the hash set, and I think this is the one I least understand. So hopefully I can explain it well. But basically, we're going to do the same thing we've done in all the previous classes, and create a private hash set and set it to reference the set that we're getting from test collections. It's going to get a single string, and that's the value we want to enter into the set, because hash sets are like a type of set. The produce method only gets one string, and then we just use .add to enter that string into the hash set. And then that returns only true and false, for what I can tell, when you do hash set.add. So if with the hash set, it's only unique, so you can't have more than one. There's no duplicates, so it would return false if there was already a hash set in there that was basically, if that hash set already exists. Sorry, that hash set element already existed. Let's see here. So if we go to test collections, it's just basically going to tries to remove Java, and that should reply true because we enter Java up here. This is like just setting how big it's going to be. Once it's removed, it should be smaller. And then we enter py in, and then we try to enter py again, and this is saying it should be false. So if we run that by itself, that also works. So that's all I have for my code here. If I run the whole thing, all four tests come back true, or like all pass basically. So regarding some of the other stuff, so lists, from what I understand, are ordered collections. So they're ordered, unlike the hash, unlike sets and maps, but they do also allow duplicates. So that would be, I guess, good for if you're storing people's names, like if you're doing, I don't know, like a class roster or something like that, and there's two John Smiths, you need to be able to, or two Johns, you need to be able to keep duplicate elements. Sets, from what I can tell, do not allow duplicates, and they don't have order as well. So it is, it might be harder to like, in some ways it might be harder to know where like each element is in that set, but most of the time you can just call using like the keys basically, right? So like this hash set down here is we're just using the name So it works as like a key, like we take the whole thing out. And then lastly is the hash maps. Oh, sorry, maps. And they also don't allow duplicates, but each key maps to one value. Um, and they don't also have any specific order. So it's useful. I think the hash maps might be the most like interesting because you can like really, if you have like a key and then it maps to something else, so it would allow you to like, if you have like a really big, I don't know, string or something, and obviously you don't want to have your like call on using that string to find it, you can use just a key, which could just be like the letter, like a single like digit, basically like 2, and that would call on the desired string. Um, and let's see, there are also hash maps. From what I can tell, they're faster for lookup than hash sets. So I guess efficiency wise, like a hash map would be better. Hash tables, hash codes, collisions. So from what I can tell, the hash map, they use a like a data structure, which is a hash table, to hold like key value pairs. So like the index and the value. Each hash table store their data in an array. So you have so the hash table is an array, and each array is like the index of where the keys are stored. So, but the indexes aren't the same as the keys. They're computed using the hash codes. So, like a hash code, from what I can tell, is like just an integer, and that's gonna be like referenced to the key. So you would have like the data, the the hash table data structure is gonna have an array. Each array has a hash code number, and those hash code numbers reference uh, to the key, the index key, I guess, like that we get from the hash table. Um, so if the hash code is 10 and then you look in the array location 10 for the hash, that would give you the hash table element. Um, so if the two keys have the same array location, so that's when you have a collision. And there's basically each uh, element in the array for the hash table has a linked list that will hold that is used to hold the key. So basically, if there's multiples, you just have like the linked list gets longer. And I think in the textbook it said that if they get like your ideal hash maps and hash tables are going to only have like either an empty linked list or like one for linked list, because if there's more than one, that's when you're running into a lot of collisions. Um, the size of the array for this hash table, um, so the size of the array for the hash table has to be larger than the hash table. So I guess every time the hash table approaches the same size, like the elements in the hash table approach the same size as the array, a new larger array is created, and that's why it's like harder to order these, because at that point then the new the new array will change up the order. Um, and then lastly, you can use like comparators, from what I can tell, to basically do like a custom sorting for your data. So like a tree set is a type of sorted set. And you can either if you use a tree set, it's going to either use the natural order of the entries, or you can use a comparator to kind of set up a custom entry. So if it's doing like numbers, it's going to be like 1 2 3 4 5, and you can reverse that, so it's like 5 4 3 2 1, something like that. I guess with strings you could set it up to be like based on their length, based on the alphabet, something like that. So that's all I have today. I know this was a long video. Thank you.